Hi guys. So last time we talked about section 7.2, and then in there we learned the definition of six trigonometric functions and how to find six trigonometric functions given some information such as like a triangle with two side lengths, or just like one trigonometric function such as the value of sine or something like that. The way that we can get to all six of trigonometric function is that we can do it by using the definition of six trigonometric functions, SOHCAHTOA, and the flip of them for cosecant, secant, and cotangent. Or the second way to get all six of them is that we can use the table of the identities. We have three types of identities. The first type is the reciprocal identities. Well, we have sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. The second type of identity is about quotient identities, where we have tangent equals to sine divided by cosine, cotangent equals to cosine divided by sine. A tip for this one is that remember that the order of SOHCAHTOA, it goes by SO first and then CA second, right? And then lastly we have TOA. So tangent equals to sine first divided by cosine secondly, okay? And then lastly we also have Pythagorean identities. I told you guys there are three of them. The first one is sine squared plus cos squared equals 1. Second one is tangent squared plus 1 equals to secant squared. And the last one, cotangent squared plus 1 equals to cosecant squared. You don't have to remember all three of them because I know, like personally, it's really hard to remember all three of them, and then you might have more to remember later in the course. Just make sure that you have it down somewhere in a sticker, in your note, or in your notebook somewhere, just to get ready for the test. Okay? And then the last concept of 7.2 that we learned is about the complementary angle theorem, or shortcut CAT. In order for two trig functions to be equal to each other or have the same value, we have two requirements for it. The first requirement is that the trigonometric functions, they have to be co-functions of each other. What do I mean by co-functions? Co-functions are the ones that go by names. Like sine is the co-function of cosine, tangent is the co-function of cotangent, and secant is the co-function of cosecant, and vice versa. Okay? And then the second requirement is that the two angles that you use in there, they must add up to 90 degrees or pi over 2 in radians. Or in math, we use the word complementary to show the same meaning. Like the sum must be a right angle, or like 9 degrees or pi over 2 radians. Okay? So now let's talk about 7.3, computing the values of trigonometric functions of acute angles. Before we get to the first objective, like usual, let's review some old concept. So this table right here, I'm gonna let you guys fill it out by yourselves. Try not to look back at 7.2 concept. My trick in here, my like tips in here would be try to remember that we have SOHCAHTOA as definition for sine, cosine, and tangent. For the other three, they're just the flip of the first three, okay? So sine here, it goes with cosecant. Cosine here, it goes with secant. And tangent in here, it goes with cotangent. Remember, for reciprocal or for the flips, one C function pairs up with one non-C function. Let me carefully circle it in blue in here so you guys can see it. This one for cosecant and sine. This one for secant and cosine. And lastly, we have cotangent and tangent. Okay, that's my tip to remember, like the six trig function in the easy way. Okay, so I want you guys to fill this out by yourself. And now, before we get to the two special triangle, let me review a little bit about the 45, or should I say the isosceles triangle. And the other special triangle is also the equilateral triangles. We have two of them, right? These two are for equilateral triangles. If you notice, let me put it in blue. This triangle in here is the top half of the equilateral triangle right beneath it. What does it mean by equilateral triangle? Equals mean like they equal to each other, right? They have the same, right? In a triangle, we know that we have three angles, and we know that the sum of any triangle is 180 degrees, right? So if you do 180 divided by 3, each angle in an equilateral triangle should have the measure of 60 degrees, right? Because 60 times 3, you have 180 degrees. With that saying, each angle in here, let me put it in green. This one is 60, this one is 60, and this one is also 60, okay? Since all three angles have the same values, the three side lengths in here would also have the same value. Let me put it in, I don't know, pink. So this sign here, say if it has the measure of 2x, then this sign here also have the measure of 2x. And this sign here also have the measure of 2x. But if you want to split it into halves, this one in here would be x, and this one in here would be x. Because we have like 2x, right? So 2x divided by 2, each of them will be x. Alright, so just imagine if you have a right triangle, which is like the top half of the equilateral triangle, like here. We know that one angle in here is 60 degrees already. The right angle we have is 90 degrees. So 90 plus 60, we have 150 degrees, right? And in a triangle, the sum in here is 180. So we get 180 minus 150 equals to 30 degrees. The last angle in here will be 30 degrees, okay? If you notice, this angle of 30 degrees is half of this angle, 60 degrees, right? So the side that looks across to them will have the similar kind of like ratio or relationship. So let me erase some like other things in here so that I can show you guys. Okay, so the x in here, look across it, we have 30, which is the smaller angle. And then for the 2x in here, look across to it, we have the 90 degrees. So just remember the relationship in like the 30, 60, 90 triangle. That's another name for it. This one is like the 30, 60, 90 triangle, or if you want, you can just say 30 degrees, 60 degrees, and 90 degrees. I usually like drop out the degrees when I say it, but if you include it, that's cool. And this one, just as a quick reminder, this one is the equilateral triangle. Equilateral triangle. Let me just put like equal in here. Equilateral triangle. Like, let's just do shortcut for it. We're gonna see the English name for it in the next page. Okay. And another type of the special triangle, like I just said before, we also have the isosceles triangle. What does it mean by isosceles triangle? It means that two sides in the isosceles triangle have the same value. Specifically in here, we have this side has x in measure equals to this side also have x in measure. And notice that if we have a right isosceles triangles, then because this one in here is right angle, is like 90 in measure, these two will have to add up to 90, right? So that the sum in this triangle is 180. And since the two sides are equal to each other, the two angles in here are also equal to each other. So 90 divided by 2, each of them will be 45 and 45. Okay? That's like a little bit review for the right isosceles triangles and also for the equilateral triangles. Okay, notice that in the right isosceles triangle, the two legs are congruent to each other. Congruent in here, it means like we have the same value, okay? And then in the 30, 60, 90 triangle, one of the leg is half as long as the hypotenuse. The hypotenuse in here is 2x, and the shorter leg, it is just x. Okay, this one is the longer leg. Okay, the longer leg we're gonna know later that is equal to x square of 3 if you remember from back in the day, but if you don't, that really like doesn't matter at this point. Okay. All right, now let's talk about the first objective of today. Find the exact values of the trigonometric functions of pi over 4 radians, which is 45 degrees. All right, at this point, I really hope that everyone is comfortable with how to convert from degrees to radians, because that's like the really like basic step for us to go further Okay, so let's see. Assume that the legs have length 1. So the legs, we have this leg in here and this leg in here. Okay, you might want to ask me like, how do I know that these two in red are actually the legs, not like hypotenuse or any other sides, right? So we have one hypotenuse, only one hypotenuse in the right triangle, right? And the hypotenuse is always the side that look across to the right angle. That's how I know that this is the hypotenuse. And then the other two, they must be legs because they right next to the right angle right here. They're right next to the right angle. Notice that the hypotenuse, it never touches the right angle, right? So that's like one of the feature for us to know that, well, it's the hypotenuse because it never touches the right angle, okay? So let's assume that the legs have length 1 in here and length 1 in here. Okay, by Pythagorean theorem, we have a squared plus b squared equal to c squared. A and b in here is 1 and 1. Say this one is A and the other one is B. Again, the legs, they don't really matter the name. You can call this one A, this one B, or this one B and this one A. It really doesn't matter. They just all legs. Plus, in this triangle specifically, they have the same length, right? So that doesn't make a big difference. So we have 1 plus 1 in here is 2. And again, I told you guys, 2 is not the final answer for c squared because of the square, right? So in order to cancel the square, we have to take the square root of both sides. And hence, we have c, the hypotenuse, equals to square root of 2. Let me put it right here. Okay, so this cap setup here looked exactly like what we did in example 1 for 7.2, right? So I'm gonna do it really quick in here. So just a quick like reminder that we have SOHCAHTOA. Like that helps, right? For every time that you have to write the 6 trigonometric function out, make sure you write this mnemonic out first, just to help us out to remember what is sine, what is cosine, what is tangent. Okay, sine here, it is opposite over hypotenuse. So opposite to 45, we have 1, and hypotenuse, we have square root of 2. And then we rationalize it by multiply the top and bottom by square root of 2. Shortcut, we have square root of 2 over 2. Okay, now you might want to ask me, like, we have 2 angles of 45 in here. So which angles are we talking about in this setup? And I'm going to tell you guys it doesn't really matter because they are the same thing in here. If you go for this angle in here, then the opposite side would be this one. If you go for this 45 in here, then the opposite side would be this one right here. But if you notice, both of the legs are equal to each other. So like which opposite, it doesn't really matter at this point anymore because they all have the same length, right? They all just 1, okay? And then next up we have cosine equals to adjacent divided by hypotenuse. It's also 1 divided by square root of 2. And then rationalize it, we have square root of 2 divided by 2. Okay, and again, it doesn't matter if you go for this 45 degrees or this 45 degrees because for, say, this 45 degrees, this in here is the adjacent. And if you go for this 45 degrees in here, this angle in here will be the adjacent. And then the two adjacents in here are equal to each other, which is 1. So for this problem specifically, it doesn't matter like which angle of 45 degree that we pick, okay? And we also have tangent, TOA, equals to opposite divided by adjacent. Opposite, we have 1, and adjacent, we also have 1. So 1 divided by 1, we have 1. Okay? And then for the other column, we can just flip them out. So I told you the quick trick. I mean, you can flip this one or flip this one in here. But I'm going to flip this one, okay? Because I don't want to flip like the other one and then have to rationalize it. And then, you know, like more work. Okay? So the answer in here would be square root of 2, square root of 2. And 1, the flip of it would be just 1. Okay? And then the first example, find the exact value of trigonometric expression. So at this point here, let me highlight this one out because this is like the fact that you have to remember if you're not fast in converting from degrees to radians. So remember for the fact that pi over 4 in here equals to 45 degrees, okay? This is like one fact. If you want, you can think of it like, oh, we have 180 represents for pi, right? So instead of having pi over 4, think of it like 180 divided by 4, and if you put it into the calculator, you're going to get 45 degrees, okay? If you think that it's too long, just memorize this one, okay? Like for me, it's just like a habit now, so I got this memorized in my head already. And another tip for this one is that pi over 4 in here, it has a 4, right? So then like 45 in here is also have the 4. So let me highlight let me circle what I'm talking about in here. So the 4 and the 4, like they pair up in a sense, right? So that's another tip to remember, that pi over 4 radians equals to 45 degrees, okay? So in here, this expression here is just asking us for tangent of 45 degrees plus cotangent of 45 degrees, okay? We know from the setup that tangent of 45 degrees equals to 1, and cotangent of 45 degrees also equals to 1, right? So this in here, it equals to 1 plus 1, which is 2, okay? And again, you might look at these symbols and be just like, pi over 4, like I don't know what they are. Think of this right here. Think of what I just told you, okay? Pi over 4 is just simply 45 degrees, okay? We learn how to convert it. If you find conversion process is too long, memorize this out. And the rest of them, remember this table in here is really like a helpful tool for us to remember like all 6 values. Like later in the course, we have to remember all 6 of them, but whenever you don't remember like any of the 6 value in this table in here, draw the triangle. Like this triangle in here helps a lot. You know, like if you have the triangle set up like this, you know that the triangle will have the side length of 1, 1, and square root of 2. These 6 value, you just have to go by definition, right? And then you don't have to memorize it out anymore. But, you know, like everyone has their own way to remember the stuff, so it depends on you. Like you can draw the triangle, you can remember all 6 functions, or you can look up for another tips, okay? Next objective, find the exact values of trigonometric functions of pi over 6 or 30 degrees and pi over 3 or 60 degrees. Okay, here are 2 more angle conversion that you have to memorize. So we have pi over 6 equal to 30, and we have pi over 3 equals to 60. My tips in here is that, like, if you write it down, you will see that you have like 30 in here degrees, and then 45 degrees, and then 60 degrees. I know that it looks like this, but I'm going to show you guys why. Okay, this one in here, okay, I told you guys about the 4, right? Like, you see the 45, so that means you have like pi over 4, right? For the other 2 angles of 30 degrees and 60 degrees, well, you know for the fact that they all have pi, right? Because we're talking about like radian system, right? And then these 2 in here, you just have to swap them out. Like 30 is pi over 6 and 60 is pi over 3. Okay, that's my tip. That's like my own way to remember it. I firstly know that 45 is always pi over 4 because of the 4s. And then 30, 60, I know that they cannot be the same, so they have to be the swap of each other. So 30 is pi over 6 and 60 is pi over 3, okay? That's just some tips for you guys to like remember these 3 conversion in a fast way. But if you don't want to, again, you can do like 180 divided by 6 and so on, right? Just like what we learned in 7.1 about how to convert from degrees to radians, okay? All right, so let's talk about the setup of this triangle in here. Assume that the shorter leg has length 1. So first of all, we have 3 sides in here, and the easiest thing to identify in here is always the hypotenuse, because first it's opposite to the right angle, and second it has no contact whatsoever with the right angle, right? So this in here is the hypotenuse. Now we have 2 sides left. Just by eyeball that, you guys can see which one is shorter and which one is longer, right? So this one in here is the shorter side. It has length 1 by the setup. And then this one in here is the longer side, okay? Okay, so we have this information. We know that the hypotenuse in here must have length of 2. Some of you guys might ask me, well, this looks like 2, so why isn't it 2? And I'm gonna tell you guys this. Okay, first of all, this is not 2. Okay, and then let me draw the complete equilateral triangle of this. And remember, this triangle in here is just like the top half of an equilateral triangle, okay? So this is 60, this is 60, and this is also 60, okay? Half of it would be 30, but if we talk about like the full angle, like the one in the big equilateral triangle, not the one in the top half triangle, then it's 60 also, okay? Just imagine if this portion in here is 1, then this whole part in here, let me put it in pink then. This whole part in here is 2, right? And because we're in an equilateral triangle, this is 2 and this is also 2. This is why the hypotenuse is 2. Because of the position and because of the equilateral triangle. Okay? And again, in a right triangle, if we know 2 sides already, we can use Pythagorean theorem to find the third missing side. And let's do that in here. We have a squared plus b squared equals to c squared in here. Let's say this is A, this is B, and this is C. B is the missing one, so we're going to have B squared equals to C squared minus A squared. We have C equals to 2, we have A equals to 1, so we have 2 squared minus 1 squared, which is 4 minus 1, which is 3. And again, this is only B squared, not B. So in order to cancel the square, we have to take the square root of both sides. And then we have B equals to square root of 3. Okay. And then let's talk about the setup in here. Alright, just like before, this is similar to example 1 that we had in 7.2. And it's also similar to the first objective that we did earlier. So I'm going to do it really quick in here. Sine here is sine of 30 degrees, right? It equals to opposite divided by hypotenuse. So let's remind us the definition of the sec-trig function by writing SOHCAHTOA. Okay, and I'm serious, this is like really useful, so if I see it on a test, I'm not going to laugh at you guys or anything like that. Okay, so make sure you write that just to remind yourself the definition of the sec-trig functions, okay? Sine of 30 degrees. First of all, let's look at the angle, 30 degrees. Okay, first of all, let me erase some stuff in here so that we have more space. Alright, so now for the first setup in here in red circle, we're focusing on 30 degrees, this angle right here. So opposite to it, this is the opposite, okay? And again, hypotenuse is only hypotenuse. We only have one hypotenuse. Hypotenuse is the one that always like stand out from the outer sides, right? So that's like the first thing that we have to identify. And then since we have opposite, we have hypotenuse already in a triangle. The last sign here, it is adjacent, okay? So now sine opposite divided by hypotenuse. We had earlier this one by the setup, it is 1 adjacent in here, I'm not wrong. This is square root of 3 and this is 2. The one I just erased earlier, but right, these are the values for them. So opposite in here is 1, hypotenuse in here is 2. And then cosine here is adjacent divided by hypotenuse, so it is square root of 3 over 2. And lastly, tangent, TOA, we have opposite divided by adjacent. And then we rationalize it to get square root of 3 over 3. Okay. If you notice, we didn't do anything to rationalize this fraction or this fraction. Why is that so? Because the fractions in the pink circles, they don't have any squared or rational or radical functions on the denominator, okay? So if you have like no square on the bottom, keep it, leave it. They're fine, okay? Like it's fine to have just a number on the bottom. That's like great. Okay, to handle the second column, we flip them. So 2 over 1, we have 2 in here. This is 2 divided by square root of 3. Rationalize it, we have 2 square root of 3 over 3. And lastly, I'm going to flip this one in here to get square root of 3. Okay? And for your part, I'm going to put a green star in here. This is like one of the things that you have to do. For your part, notice that we're not going to look at the angle of 30 degrees anymore. So let me erase this thing. Okay, for your part, notice that the angle in here is different. It's not 30 anymore, it's 60. So we're looking at this angle right here, right? So opposite to 60 is this sign instead. Okay? And then since we have hypotenuse, we have opposite already. So the last one will be adjacent. Okay? So once again, like a really quick reminder before you make this mistake on the quizzes or tests. Adjacent and opposite, they are relative. Depends on which angles you choose in a triangle. Okay? A sign, it could be opposite to one angle, but it could be also adjacent to another angle. Okay? It really depends on which angle you're using. They not always stay as opposite and adjacent. Okay? Only the hypotenuse stays the same for like any angle that you're looking at, because there's only one hypotenuse. But opposite and adjacent, again, they change depending on which angle you use. Okay, so green, this is your part. Okay, for the second example in here, pattern in the sine and cosine functions in the following angles. Okay, I know that you can look up this table online and then you can find out all the information that you have. But here's my tip. First of all, have the setup of 30, 45, and 60 in increasing order. Now you can do counting. Okay, I kept like add up this column and this column up 0 and 90 in there. They are like cool to remember because they follow the pattern that I want to introduce you guys. So here's the tip to remember this table. You just have to number them. Actually, you do 0, 1, 2, 3, and 4. Simple enough, right? Just like counting from 0 to 4. And remember, the order of it has to be like 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay? There's a big jump right here. It's not like 70 up next or anything. It's 90 right there. So make sure you don't trip over this. Okay? And here's the second step. You're going to take the square root of everything. Square root of 0 is 0. I'm not going to write a square root in there. Square root of 1 is 1. Square root of 2 is a bad number. So let's just keep it as square root of 2. Square root of 3 is also a bad number, so let's just keep it as square root of 3. Square root of 4, we have 2 right here, so let me just put like 2 in here. And then, third step, divide everything by 2. And these are the value that you're looking for. But first of all, let me simplify this thing because it looks annoying. 0 divided by 2, we get 0. And then 2 divided by 2, we have 1. Okay, so if you know this, let me put it in, I don't know, blue. These values in here matching up with the one that we found in earlier. So psi of 30 equals to 1/2. Psi of 30 equals to 1/2. Okay, and if you do the right thing, psi of 60 in here, this in here should be equal to square root of 3 over 2. Okay, and then as for cosine, we're gonna do the opposite procedure. So we number them, but from like in the other way. So we do 4, 3, 2, 1, and 0, and then again we take the square root of everything, and then we divide them by 2, and then this is simplified to 1. This is just square root of 3 over 2. This is square root of 2 over 2. This is 1/2. And this is just 0. Okay, and make sure you remember the order of this table also. Like the setup is very important in the sense that if you mix up the order of one of them, all the information within a table will be wrong. Okay, so for the horizontal like boxes in here, the angles have to be from least to greatest, and for this in here, it has to be in SOHCAHTOA order, meaning sine, cosine, and tangent. Okay, and then we learned from the last section from 7.2 that tangent in here, it equals to sine divided by cosine, right? So if you do 0 divided by 1, we have 0 in here. If you do 1 over 2 divided by square root of 2 over 2, the 2's canceled out, and you're going to get 1 divided by square root of 3. We rationalize it to get square root of 3 divided by 3. If you do square root of 2 over 2, well, the 2's canceled out, and then also the square root of 2's, they also canceled out, so we get 1. This is just like when you have 4 divided by 4, or like, you know, like 10 divided by 10. When you divide this, like a number by itself, we always have 1, okay? And then lastly, square root of 2, square root of 3 over 2 divided by 1 over 2. The 2's in here also canceled out. And then square root of 3 divided by 1, we have square root of 3. And in here though, this one is the interesting thing I want to mention. We have 1 divided by 0. And if you recall from like back in the day, anything divided by 0 cannot be defined. So I'm going to put D and E for does not exist. Okay? Alright, let's get to the next objective. 3. Use a calculator to approximate the values of trigonometric functions of acute angles. Alright, for this activity in here, you're going to need a calculator. I can assure you I'm not going to like have you do something like this on the homework or on the exams, on the assessment. But this is good to know. Why? Because later on in the future, you might use some like program when you work or for any job, I think. And if they ask you like psi of like 10 degrees for like measure like how much or how long you have to like build I don't know, a bridge or something like that for engineering or like for something for your major, you might have to know the answer to all those questions. Okay. So first of all, before you use a calculator, make sure you turn it on and then set the calculator in the correct mode. Okay, so then, okay, first of all, scroll it up a little bit. All right. Make sure you have the correct mode. What do I mean by correct mode? If I have the degrees in here like this, that means degree mode. If I don't have the degrees at all, like this, or if I just have you guys do something like, I don't know, this, where you only see the number but no degree, like with no little circle on the top right, it means radian mode, okay? How can you switch from degrees to radians and vice versa for the mode on the calculator? There's like tons of calculators out there, so I don't have the answer to all of them, but I'm pretty sure YouTube can show you guys how to switch from degree mode to radian mode on your calculator. If you can just search your calculator name and then just like degree mode or like radian mode, I'm pretty sure YouTube will have the instruction for you guys to do that. Okay, it's in the setup of the calculator. I personally have like the Casio, so I'm not like super like expertise in the TI, but you know, like YouTube is really helpful. Alright, so for example in here, this one in here, since it has the little circle on top of the 34, is in degree mode. And this one in here, it doesn't have that little circle, right? So it's in radian mode. Okay, so again, if you have this little circle, degree, else radian. Okay? Okay, that's step 1. And step 2, input the desired mark key. So in the calculator, we only have psi, cosine, and tangent button. But we have like 6 functions, right? So how can we do that? I'm going to show you guys how to do the other 3 in a second. Okay? So in order to do the other 3, for example, like cosecant, secant, and cotangent, we're going to use a reciprocal identity for it. Okay? So we know that cosecant is a flip of sine, secant is a flip of cosine, and cotangent is a flip of tangent. Okay, so for example, say if I want to do cotangent in here, and there's no cotangent button in the calculator, I'm going to do 1 divided by tangent of that same angle. So for this example, it is 125.6 degrees. Okay, another like common mistake that I see a lot of people having is that they do 1 divided by 125.6 degrees. This is wrong, okay? First of all, like if it's just about a number, then what's the meaning of having the function right there for the problem, right? It makes no sense for us to just have numbers. And secondly, if you do tangent of 1 divided by the angle, this is also wrong because you changing the angle is not the angle itself anymore. Okay, like in here you have 125.6, but in here I'm pretty sure because you flip it already, it's not going to be 125.6 anymore. Okay, And another like common mistake in here that I see a lot of people having is that you do 1 over 125.6 tangent. Okay, this is wrong. Okay, like tangent in here, whatever function that you're using in here, it has to be in front of the number. It cannot be after the number or the angle. It's just illegal input. Okay, your calculator will show error and it's gonna tell you like this is error. You cannot go further, and then that's when you know you have to switch back the function to the front of the angle instead of having it on the back. Okay, so these three are the common mistakes. I don't want you guys to have it. I don't want you guys to use it anyway. Okay, so make sure you don't do these. Alright, so for the first one in here, if you have it in gradient mode, you can input cosine and then open parenthesis. If your calculator already had the parentheses, don't do second parentheses, okay? Like, that's not like help it. That's not helpful. Okay, and then you do 4, and then there's a pi button in there. If you look over your calculator, there's a pi button. So just go ahead and use it. Some calculator you have to use like shift and then another button, or some other calculator you have to do like second and then like another button to get to the pi. But I don't know, it depends on the calculator. Okay, so in here just like really you input it into the calculator and you get the answer. So let me do it in pink. The first one I got 0.67. The second one I got negative 0.72, and then the last one I got negative 0.90. Okay, one thing I want to point out in here is about the sign. Okay, so even the angle is positive, it doesn't mean that the value that you got out of it is positive, right? A counter example would be the second one. Like this one, as you can see, the angle is positive, but the value in here is negative. And some other time, the angle in here is negative, but then the value is also negative. So it really depends on the angle, okay? So please don't take into account about the size of it. Just because you have a positive angle, it doesn't mean anything about the size of the value at all, okay? So let me put a green star on this one. So these three would be your part. These are your turn, okay? So enough talking about a calculator. Let's talk about application. Okay, last objective of the day. Model and software apply problems involving right triangles. The key to the right triangle, the key is the right triangle. Okay, so whenever you see the symbol of like 3 stars in here, like this symbol in here, it means like those are my tips. Like from my experience when I was from like student and when I'm like reading books and teaching you guys, these are from like my personal tips. Okay, so for applications in here, because we're learning all about like right triangles to this moment, right? So if you have any word problems, don't freak out, okay? First of all, don't freak out. I know what you think, but yeah, don't freak out. First of all, draw a right triangle, okay? It can be a standing right triangle or like a laying down triangle. It doesn't really matter. It depends on the problem actually. But just like whatever you do, first of all, draw a right triangle. It cannot be any random triangle, okay? It has to be a right triangle. So for my example in here, I already have the picture. So let me zoom this one out a little bit in here. And as a first like glance, if you look at the picture, the triangle in here is not even right triangle, right? So let me split it into 2 right triangles so that it's easier for us to work with it. So we have this triangle on the left, and we also have this right triangle on the right. Okay, now let me do the label system for this. So we know that this is like 500, and this is like, we split them out, but they like the same size. So this is also 500 for the other triangle. Now let me label the sign here. This is the soldier field, and then this is the Adler Platinum or Planetarium. Okay, this one in here is the balloon, the plim. Okay, they call it the plim. So let me just write the plim in here. And then this one in here, I'm gonna call it grass because it's just like, it's not labeled in the picture, so let's just call it grass. Alright, so notice that in here we have the angle of 32 degrees, right? And it's a right triangle in there. Okay, let me put it in pink. Okay, let me put back. Okay, this angle in here is 32 degrees, okay? So if you want to figure out the angle inside a right triangle, this one in here, what do? We're gonna take 90 minus 32, and that is 58. Okay, some of you guys might ask me like, well, I didn't even get to read the whole problem yet, right? So how do I know if I need to do this or that? I'm gonna tell you guys, first of all, I need to get like all the information that I can from the picture first, and then after that I'm gonna read the problem secondly. Okay, so that's usually my habit. Like if you don't want to do that, you can do it in your way. You can read the whole problem first. This is like the thing that people usually do, and you know your questions, and then you get back to find all the information that is given from the problem, and then from there you solve your problem, right? I usually do it in the other way. I like label all the things first and then get to the question secondly. But again, this is just like my style, so you don't have to do it my way, okay? Like you can do it in your own way. And similar things in here, we have 23 outside, so in the inside we're gonna get 90 minus 23, which is 67 on the inside. Okay, and then this angle in here, how can we do that? Because one triangle, in any triangle, we have 180, so that one in here we can calculate it by taking 180 minus 90 minus 58, and then we get 32 in here degrees. And then similarly we can do the same thing over here, and we're gonna get 23. Okay, so we get all the angles inside these two right triangles. That's great. So now we got this down ready. The 500 we got it labeled down, the 32 we got it down to, the 23 we got it down to. And then now the question is, find the distance between the Soldier Field and the Adler Planetarium. They're talking about this distance from here to here, right? So how can I find this distance from here? Okay, let me put in another color. Let's use blue. Okay, how can we find this distance and that distance? Okay, well, you can do it like separately. You can find this one first, you can find this one secondly, and then you add them up, and then you get this gap in between them. Okay, alright, so let me erase this because it looks annoying. And now let's talk about the procedure of how to do this one. Okay, so let's see, we know all 6 trig functions, right? How can we do it? Let's use a variable for it. Okay, because I used blue already, so let's call this side x and the other side y. I'm really bad with like names and like letters, so you can call it like AB or your names even, or anything that you want to, okay? Like you don't have to go by x and y. If you do, that's fine. If you don't, that's also fine. Okay, so how can we find x in this triangle in here? Well, you know that you have 500, right? For each triangle, you have 500. That's one of the side length, and you have to find x. Okay, so notice that the 500 and the x in here, they are right next to the right angle. So it means that we have between adjacent and opposite of something. Okay, we don't have, or we don't know, or we don't need to know anything about the hypotenuse in this triangle. Okay, and if you recall the definition of SOHCAHTOA, let me write it in here. SOHCAHTOA. The only occasion or the only function among the 3 in here have opposite and adjacent, or should I say, the only function among the 3 in here that doesn't have hypotenuse is tangent. Okay, so I hope you guys see where I'm going to. Alright, so let's set up tension for, I don't know, 32 degrees. I'm gonna do it in two ways, just in case you guys ask like, why do I pick on the 32 degrees, not the other angle of 58 degrees. I'm gonna show you guys how to do it in two ways, okay? But I really hope you guys see why we go for tangent, not for sine or cosine. Again, we don't go for sine cosines because we don't have hypotenuse and we don't have to find hypotenuse, okay? So tangent of 32 degrees equals to opposite divided by adjacent. Opposite to 32 we have 500, and adjacent to it we have x. At this point, I really hope you guys see which one is adjacent, is opposite, and which one is adjacent. Like, I think 2 out of 20 people might have this problem of identifying which one is adjacent and which one is opposite. If you have those problems, please let me know. I'll try my best to help you with that, okay? And then now, since I show you guys how to use a calculator in objective 3 of this section already, so let's put this in the calculator. Okay, so we have tangent of 32 degrees, and make sure your calculator is in degrees mode. It equals to 0.62 if you route it into 2 decimal places. Okay, and then on the right hand side, let's just rewrite it as 500 divided by x. At this step, imagine it like 0.62 is 0.62 divided by 1. And in here, because we have 2 fractions, and in between we have an equal sign, not multiplication sign or anything like that. It's an equal sign, right? So again, we have the tool of cross multiplication. Okay, and in here we can do 0.62x equals to 500 times 1, which is 500. And from there, we're going to divide both sides by 0.62. And then we get x in here equals to 800. Well, 0.17, because we have to route it into like 2 decimal places, right? Okay, that's only x. We got x down, right? How about y? We're gonna do the same procedure pretty much, right? Because we have the same situation in here. We have 500, we have y, and they are both close to, or like next to the right angle in here. Again, we don't have any information about hypotenuse. We don't need to find the hypotenuse in here. So whatever among the 3 that have hypotenuse, we're going to cross them out, okay? And the only option that we have left in here is also tangent, okay? So let me take this out of the way first. And let me do it in red. Okay, for the second right triangle in here, if I have the setup of tangent of, I don't know which angle you guys want to go for. The last one I choose the bottom angle already, right? So this time let me just do the top angle, 67. And the secret is really doesn't matter at all. Like, as long as you identify the right thing to do, like as long as you identify which one is adjacent and which one is opposite, then you cool, you safe. Okay? So then tangent of 67 degrees, it equals to opposite. We have y, and then divided by adjacent, which is 500. And then in here, again, use a calculator, input tangent of 67. That gives us 2.36. This is my 6. Okay, and make sure your calculator is in degree mode because we have like everything in degrees in here. Okay, and then we have y divided by 500. Again, imagine there's a 1 right there, and then we use cross multiplication, this and that. We have y times 1, which is y, and then 500 times 2.36, which is 212.24. Okay, now that we got y, we're gonna add them up, right? Because they want to know the distance between the Soldier Field and then the Adler Planetarium, right? So we're gonna do x plus y. In here I got y already, so I'm just gonna do that plus 800.17. I mean, you don't have to do it by hand, right? And you don't have to do it mentally also. You have the calculator. So let's just input it into the calculator and get the answer as 1,012.80, I mean 0.41. Okay. If you have any question on this one, let me know. Okay. If I make a mistake or if you're not sure about any step in here, also let me know. Okay. And this one, make sure you don't forget the unit in here for the final answer. For x and y, if you forget the unit, I'm cool with it. But for the final answer, this one, make sure you put on feet. And they're talking about the distance, right? And then box it. Okay. And then as a matter of fact, like I promised you guys earlier, there's two ways to do like each triangle. So let me put in, I don't know, purple. In the second triangle in here, if I don't want to go for the angle of 67 degrees, I can do tangent of 23 degrees, but then the position of opposite and adjacent will be different, right? So opposite to 23, I have 500, and adjacent to it, I have y. As you can see, the setup is different, right? The setup is very different now. For 67, y is on top, but for 23, y is on the bottom. Okay, and same thing, you input tangent of 23 into the calculator, you do cross multiplication, and you find y. Okay, and then same thing goes for the first triangle in here. Let me do it in brown. If you don't want to go for the angle of 32 degrees, you can actually do tangent of 58 degrees. And in here, opposite to 58, we have x. Adjacent to it, we have 500. Okay, and again, input it to the calculator, do cross multiplication, solve for y, solve for x in here. Okay. All right, so those are the two ways to do this one, but I just want to stress out one thing real quick in here about word problems for this lecture so far, for this video, for this section so far. Make sure you put everything into right triangle like this and that, because if you keep and everything as just like triangle, like normal regular triangle, it wouldn't go anywhere. Like it wouldn't help at all, not even for your thinking, not even for like any procedure. Okay, at least for me, I cannot think any further as I see this picture just by itself. I have to break it down to this and that, and then I know what to do. I know like which of the three SOHCAHTOA function to use for each circumference. Okay, so that is the end of this lecture. So let me know if you have any questions or concerns. Okay, thank you and bye bye.